Good morning, everybody. Welcome to the Friday morning West Coast Space Show program. I am your host, David Livingston. Thank you very much for tuning in, and great to have you there. Uh, we have a new topic for the space show today, although, as I've been saying before the program started with our guest, uh, nanotechnology has been part of many, many space show programs over the 25 years. But to the best of my memory, I don't think we have ever done a standalone focused program on the topic of nanotechnology. So our guest today, science writer Rahul Rao, who is in New York with us today, is going to be our first dedicated, focused guest on nanotechnology with his new book that is out. It's available on Amazon and probably other places as well, Nanotechnology. This will be a 60-minute format. Just for a couple of other big things, Sunday, we have an open lines discussion. That's Sunday, April 12th. And Tuesday, we have a really interesting author on a different take on the International Space Station with a book, James Van Laak, Laak, if I got that correct. Friday, another interesting show. Look it up on our archive. But Shabar Ali, who's been writing some op-eds off of Space Cynics that he has resurrected from what myself, Tom Olson, Dr. John Jurist, and Shubber created about 15 years ago, will be the guest. So we're happy to reconvene with Shubber. More detail, of course, will be on the website. But our guest today and author of the new book, Nanotechnology, is Rahul Rao. Uh, Rahul, welcome to the Space Show. We're glad to have you on, and we thank you for being with us.
You for having me on. It's a pleasure.
Um, why don't you start out and introduce us to your work and to your book and your interest in nanotechnology and its connection to space? Because you said you're both a science and space type of journalist. So nanotechnology and space would be a good focus, along with science, of course.
Right, of course, yeah. So, yeah, as David mentioned, I'm a science writer and science journalist. I've been doing this for several years now. I mostly cover topics related to a broad array of physics and space topics, particularly things like particle physics and materials, and how those are used on space missions. And in covering this broad range of topics as a journalist, I keep noticing that there's this common thread of many of them use what we would think of as nanoscience, as like manipulating things on very small scales or using nanomaterials such as graphene or carbon nanotubes. And that's really what sparked my interest in this, in covering and writing this book, because there's these, even though there's many ideas of what nanotechnology is, but some of them are just so commonly used in all sorts of science and engineering areas that I thought it'd be interesting to really cover many of them at once. And that certainly includes space, as this is certainly not a new idea, but one of the great dreamlike promises of nanotechnology is that it will deliver us materials that are strong enough to build things like space elevators, for example.
When was the field sort of coined or established as a field? When did the term start applying to it? Was it World War II? Was it after World War II? What can you tell
It
us about the
was,
origin history?
yeah, so it really, it really, humans have been unintentionally using nanotechnology for many centuries, but it really took off in the decades after World War II when from the 1950s when technology and scientific knowledge had advanced to the point where it was possible to really start playing around in that realm. One of the big one of the big events in the history of nanotechnology, so to speak, was a talk that Richard Feynman gave in, I believe, 1959, if I recall, where he really described this. He didn't use the word nanotechnology for it, but he used the idea of creating very small things, like, for example, a car made out of individual molecules. And he suggested that we might be able to really use that realm for industry, for building things. But even then, nanotechnology as a field still took several decades after that to really develop. And it was only in the 1980s and 1990s or so that scientists were really able to do things like create art by manipulating individual atoms and create materials that were individual atoms thin. So, for example, one of the most famous nanomaterials is the carbon nanotube, which was discovered in 1991. And that's, I think, if I had to put a single date on it, that's kind of when the field sort of entered its current state.
And its expansion and growth, is it unlimited? Does it have boundaries? How do you assess going forward 30 years later?
Yeah, again, there's many ideas of what nanotechnology is. What it currently is, really, which is using nanomaterials, which are materials that take advantage of properties on very small atom scales, for example. And those have so many applications that it's difficult to overstate just how useful they are. So, in that sense, I think the boundaries there are really dependent on our ability to make those nanomaterials like carbon nanotubes and graphene. But there's also the idea, as I think many will imagine nanotechnology to be this idea of creating machines on the atomic scale, the molecular scale rather, where like machines that can manipulate individual atoms, assemble them into molecules, things like that. And I think based off of the current science, where exactly the boundaries of that lie are still unknown. Is it possible there are some who think it's possible to use that to create something like the replicator from Star Trek, in which we're able to just assemble things atom by atom, anything we like. And whether that's possible, I don't think anyone really knows the answer yet.
So I'm fortunate that your publisher in her promotions to me for this program sent me an electronic, I guess, author copy of the publisher copy of the book. So I have the table of contents with me. It's almost 200 pages, so I didn't print out the whole book for this.
Mhm.
But I'm when I was going through the table of contents, which I always look at in detail before I start reading a book, Chapter 8 stands out, Nano Dreams. So I started the space show in 2001,
Mhm.
and by 2004, I think, 2005, I was meeting up with all of these physicists coming out of the national labs in New Mexico
Right.
and writing books and telling us that lo and behold, space elevator was here because carbon nanotubes would be the elements and we could do it from someplace near the equator and it would be wonderful. And voila, the future is here. So here we are, 2026. There is no space elevator. When I hear it talked about, it's maybe possible for the moon, maybe possible for Mars because of the difference in gravity. are nano dreams for real, or are they people fooling themselves? What's a nano dream? Because we all thought I did shows about the space elevator
Right.
launching from Earth, with cables 60,000 kilometers long going this way and that way. Um, Nano dreams. Talk to us about it.
Yeah, sure. Yeah, this is as I this is sort of what I touched upon earlier, that what people imagine might be possible with nanotechnology in future. This is really what that chapter is all about. And the space elevator is very much one of those things. And you are right in the sense that people have been talking about it for such a long time, but we haven't really seen any progress on that. And really one of the biggest challenges there, and something that really is currently holding the field back, is that it's just not to create something like a space elevator. We need to be able to create the materials for that, whether that's carbon nanotubes or graphene, at a very large scale and with very high quality. There has been a lot of progress towards making uh, the materials at a large scale, but the problem with that is that the carbon nanotubes and graphene you get out of that are just too defective and not quite strong enough to create something like a space elevator. So for the moment, it's still in the future. I've heard people compare it to fusion in the sense that still it's eternally some distance away. But I think this speaks to kind of the unglamorous nature of a lot of science, in that there's not going to be a single breakthrough that makes that possible. It's just incremental improvements. But I think if the space elevator right now serves any purpose, it's as a useful end goal to work towards.
So on the positive side,
Mm.
we do have carbon fiber tennis rackets.
We do,
We do
yes.
have carbon golf clubs. I have a carbon fiber violin bow, which is absolutely amazing. And that was never part of the dream of carbon nanotubes, but they're really cool devices and affordable.
Hey,
Um,
yeah, Dave, keep in mind carbon fiber is not carbon nanotubes. They're completely different technologies.
no, I understand that, but for
Yeah,
the general public, which some of our audience includes, uh, the distinguishing the differences is not something that they know the differences. Oh, carbon nanotube for space elevator. Oh, I have a carbon nanotube tennis racket. So they don't know the difference. So I'm just, for convenience, putting them together. Phil, if you can, in one brief sentence, explain the difference to the audience, because you are an engineer and I'm just a radio guy. Uh,
sure.
Carbon nanotube versus carbon fiber.
So carbon fiber is a real industrial material. I think it's one of the most cost-effective materials with a low weight and a high strength. But it is a little bit more difficult to fabricate than things like aluminum. They're using it in airplanes. That the Boeing 787 is made out of carbon fiber, and lots of sports equipment uses carbon fiber. Carbon nanotubes are on the other hand, are a different kind of, it's a tubular shaped crystal that is grown in the lab. And in theory, if you could grow one that was very, very long, you would have a very long strand that you could make into a cable. But so far as I know, the technology hasn't allowed us to grow very long ones. They can only grow microscopically short ones. And when you put them together, they don't make a very strong material in mass. But the individual fibers, like lots of individual fibers, in fact, are very, very strong. And theoretically, if you could scale that up, you would be able to get a strong cable. But nobody's been able to scale any of these materials up
Yeah.
So
to a
the
large scale.
fiber industry is very heavily commercialized into sports and all sorts of other things.
Yeah.
But the nanotube is a nano dream, I guess, right?
Yeah.
Yeah. I think it's sort of like a lot of people imagine what would happen if you could take a small thing and scale it to a very, very large scale. If you could somehow grow a very, very long one, that would be amazing. But for some reason, like when you grow, like you got to imagine this is like making a shoelace that's 1 billion miles long from a molecular point of view. It's very difficult to make 1 billion mile long shoelace without any defects in that shoelace. And if there's a single defect, it's useless.
Um, what attracted you to wanting to write this book and delve into um, carbon nanotubes? What was
Yeah,
the attraction point or points, if it's plural?
sure. Yeah, I mean, as I mentioned earlier, it's just that these nanotechnology or nanomaterials, even if we can't build space elevators yet, they still have loads of other applications across so many different fields. And that's the fact that this is even though our image of nanotechnology might be things like the space elevator, the reality of it is perhaps less glamorous, but certainly no less important applications across really all sorts of science and engineering. I think the best example is somewhat removed from carbon nanotubes. It's mRNA vaccines fundamentally work on a sort of nanotechnology. So while again, perhaps we don't have kilometers long carbon nanotubes, we do have the ability to manipulate biological matter on the similar scale. And in doing so, scientists have really been able to save millions of lives through nanotechnology. And I think those sorts of stories are really what I wanted to highlight.
Do you have a favorite story?
Yeah, I think probably that's a good question. I think the one that really stands out to me is that there's a type of nanomaterial called an MOF or MOF that is essentially a bit like you take molecules and assemble them into a pattern that's something like a rug, like the pattern you see on a rug. And what you get with that is a molecular structure that has loads of space that you can use to hide other substances, other molecules inside them. And that is quite powerful in many respects, but the perhaps the most powerful one is that you can use it to store away CO2 from the atmosphere. And that's one of the most promising ways of CO2 removal that I'm aware of. And I think that again speaks to the what you can do with this molecular scale, even if it's perhaps not immediately glamorous, it's still quite useful.
What is the
Marshall, you have
TRL
a
for that
question?
technology?
The TRL, sorry.
What is the technology readiness level of that particular
Yeah.
application?
It's very much still in the lab, but it's uh so it's not there are there are similar substances that are currently being used at pilot projects, but it's not something that's used up quite at scale yet.
Marshall, you want to jump in?
Yeah. Yes. One of my favorite technologies over the last 4 years is a thing called 2DPA-1, which stands for two-dimensional polymer A, first one. And instead of being like a string, it's basically a flat surface of polymers, and it's supposedly as tough as steel. But over the last 4 years, they haven't really done too much with it, other than figure out better ways making more of it. Uh, but this is one of those things about a technology shows up, and there's a huge time lag before people can make useful things out of it. And can you address that over history, and have we shortened up the lag time to make useful things, et cetera, et cetera.
Yeah, I mean, I think that's definitely, again, that's really one of the challenges with any of these materials is that it's never going to be a case of, oh, the material's discovered, it's going to instantly change the world. That never happens. But I think that doesn't mean, I think it just means we should be realistic about the timescales involved, as you mentioned. I think a good example of this in the modern world is aluminium, which we've known about it for centuries, but we didn't. It was only in the 1880s, I believe, that we were able to find a way of of extracting pure aluminium at a useful scale. But even then, it's not that aluminium became the like
Mm-hmm.
material that dominates the world that we see today. That didn't happen for another few decades beyond that until after World War II, if I'm not mistaken. So I
Mm-hmm.
think for something like the materials you describe, or something like carbon nanotubes or graphene, I think something like that is the most realistic comparison from my perspective, anyways.
I was wondering about the possibility of, if you're talking about machines and stuff, a medical application might be kind of a nanosurgery, where you would sort of create a bunch of nano type machines injected into the bloodstream, and they would target certain disease cells and wipe them out, and then maybe self-destruct at some point into something innocuous and just, flow out through the blood, normal process. Is that possible, you think, in the future, or an area of research?
Very much. In fact, it's one of that's really one of the major areas of nanotechnology research at the moment. One of the big ones is creating nanoparticles that are tuned to find certain uh, disease pathogens. For example, you can use that to basically seek out certain uh, viruses or bacteria and then deliver drugs right to them. So that's something that, that that's currently a major area of research. It's very similar to how, as I mentioned, mRNA vaccines work. But even beyond that, there's a lot of work into making more elaborate systems. For example, one that I've mentioned in the book is there's a lab that's worked on creating essentially these nano scalpels that can go inside the human body, find cancer cells, and once they're in the cancer cells, people on the outside, a doctor, for example, can manipulate them with a magnetic field. So you can imagine these scalpels entering a tumor and then sort of shredding it from within. And that's something that's already that if there's one area of nanotechnology that's got the most attention and the most research, it's things like this.
Where does that research take place? Is it in U.S. academia? Is it in the UK? Where is it taking place?
It's all over the place. The specific scalpel I just mentioned is at the University of Toronto in Canada, but it's certainly not limited to one country. If I had to pick out individual examples, I think US and Chinese academia are certainly the leaders, and probably with the UK in the same conversation.
So the space elevator folks have said in some of their presentations that there's a technology by which the cable, even though it's under incredible tension, can heal itself if it gets hit by a micrometeorite. And I was a little bit skeptical. I've never heard of any such technology to make a cable heal itself, but I was wondering if you would come across anything like that in your studies and research.
I've I've heard this idea mentioned. I think I don't know that it has been proven or tested in practice. I know it's been talked about. Maybe I'm just not aware of experiments where it's been tested in practice, but it's, I think it would certainly be nice to have.
Yeah, but you've never heard of an actual researcher doing anything or publish anything on this technology?
Yeah,
I thought
not
so.
not to my knowledge.
Yeah.
Still, I do know because when I was writing my doctoral dissertation back in the late 90s, and my Stanford professor was hammering me on this, that the undersea cables, which are not carbon fiber, were self-correcting. And that was one of the big advantages that made some of the early satellite phone things and satellite conglomerations uneconomic because if the cable broke, got damaged, it could self-correct. Now, I don't remember exactly how they did that. They were not carbon nanotubes, obviously, but I think they just found a different circuit to travel. And inside that conduit of that cable were probably hundreds of thousands of wraps of cable for these undersea networks. So they were called self-correcting, but I don't know how that worked. And I doubt that's related to a self-healing or correcting carbon nanotube. Do you know anything about that, Rao?
Unfortunately not.
But and I see now that because of launch cost and Starlink, that the undersea cables are losing their economic value for constellation satellites.
Mhm.
I think that's really interesting. That's 20, 25 so years since I published the dissertation. And so the undersea cables are even being shut down in some instances in favor of Starlink or some of the competitors. So this stuff obviously has a life expectancy. Um, do you see, what do you see for the immediate future? Is there any consumer uh, thing that's going to hit for carbon nanotube development and research? What would be the most likely? Is the medical that you talked about the most likely, or is something else out there on the horizon that consumers can say, wow?
Yeah, I think certainly for the next few years, the medical aspects they are probably going to be the ones that, if nothing else, get the most attention. But there's also, I know one of the other major things that people are interested in is we mentioned carbon fiber earlier. There's some work into creating enhanced carbon fibers that include carbon nanotubes in their material. You can imagine those being used in things like aircraft coatings or spacecraft coatings for that matter, which would so that's one area. Um, I think another there's always this idea of using carbon nanotubes to create very small electronics, very small circuits. That's something that I think is going to really start entering the picture perhaps in 10 years' time or so.
What about quantum computing? Are you seeing research taking nanotechnology and carbon nanotubes, for example, into quantum computing?
Quantum computing is sort of its own technology that's at its core relies on actually because it's usually dealing with things like subatomic particles. That's actually quite beyond the realm of nanotechnology in itself. But uh, you can there are certainly there is certainly some interest in using specifically these quantum dots, if you're familiar with them, are another form of nanotechnology that are so there's definitely interest in using those for as the core of quantum computers.
You
Um,
haven't,
I um, I saw a whole thing on quantum dots at the Consumer Electronics Show, like I guess it was 5 years ago now, where they were using them as a dye, right, to make all kinds
Yeah,
of different colors and stuff like that. How does that work? What I mean, is
yeah.
it? I thought it might be a scam actually, but is it actually a quantum material that they're actually
Yeah,
using there?
So yeah, I mean, the specific, it's hard to say without knowing exact details, but the idea, quantum dots, the idea behind them is that they are large multi-atom particles, well, large in comparison to atoms, not very much small in comparison to everything else. But the idea is that if assembled well, they take on the properties of something like an atom or a subatomic particle. So you can, one of those properties is the ability to emit light at very specific wavelengths. So if you're using quantum dots as a dye, that's probably the property that they're taking advantage of. So that's definitely
And
possible.
the other thing is they were saying they were going to use them to make televisions.
Yeah, that's
So
already happened, in
LED
fact. Yeah.
television.
Yeah. If you see QLED televisions, this is fundamentally the technology they're relying on.
Yeah. So I had another question that was sort of technical. I actually worked in a DuPont textile fibers plant at one point that made Kevlar, and they actually use gravity to make that. The machine that does it is like 5 stories high, and at the top
That's
of the
cool.
machine they have the chamber that's called the spinneret, and then the fiber falls as a liquid down the column, and by the time it gets to the bottom, they're winding it onto spools, and so they can make kilometer long spools of Kevlar or Lycra or any of the
Mhm.
synthetic fibers. What is the barrier? What's the technical barrier to making longer carbon nanotubes?
It's currently the way most nanotubes are made, carbon nanotubes are made, to my knowledge, is you sort of grow them almost like you're growing trees in a forest, so the opposite of what you're describing. And I think if this seems to be the way to create nanotubes that have the fewest defects imaginable, I think that's really what researchers are trying to work on right now, is trying to create carbon nanotubes that have fewer defects, more so than carbon nanotubes that are very long. Because for the most immediate applications, like materials that I mentioned, those it's creating less defective ones that's really more important.
So the problem is the defect rate is they can't make the fiber pure enough so that it doesn't crack. Okay.
Essentially, yeah.
Yeah, it's interesting because it's actually a very interesting process how they make synthetic fiber. It's pretty cool.
Yeah, I'd certainly be interested in hearing more about it.
You have a chapter, a 20-page chapter in your book called Nano Nightmares. Tell us a couple of the nightmares.
Yeah, so I mean, there's the very fanciful ones, which are the idea that sentient nanomachines will come and take over everything. But on a more realistic level, uh, the biggest nightmare, so to speak, is really environmental pollution because there's nano if you uh there's already, for example, like nano sized dust particles, things like that. The biggest the nightmare here, so to speak, is that those enter the human respiratory system, and they can, if they're made from the wrong material, they can easily poison cells inside the body. That's really what that chapter is about.
Is that realistic?
Yeah, it's very very much so because these are not what we call engineered nanomaterials like carbon nanotubes, which are intentionally made. These are what we call incidental nanomaterials, which are really like those exist in nature, those already exist. And if one of the potential challenges in the years ahead is that if we do make engineered nanomaterials and those escape into the environment, then they can cause problems.
Well, another thing would be the kind of reverse of what I was talking about would be weaponry. I mean,
Yeah.
suppose you use instead of doing something to cure, you create something that targets some specific group or enemy or for a period of time or something like that, and that's something that could show up too with looking at, that area.
Definitely, yeah, that is something people have discussed, but
Hmm.
I think it's as far as potential hazards go, I think it's far less of an immediate problem than environmental pollution is.
Mhm.
Hmm.
My next question is uh, the relationship between these nanoparticles and radiation. And radiation generally makes things inert, but we know that that's part of what makes modifications in our genetics and eventually makes us better, I guess. Has anybody made any issues about nanoparticles and radiation on Earth and radiation in space?
I am unfortunately not aware of any, but I think it's a great question. There's almost certainly some intersection between those.
The use of nanotechnology and these fiber particles show up in any way with human spaceflight as a potential game changer or big advantage, maybe 5 years, 10 years out.
Yeah, there's a few aspects. One is I know there's quite some interest in making and adding nanomaterials to things like spacecraft coating or thermal insulation, because one of the other advantages of carbon nanotubes is that they're some of the best thermal conductors that we are aware of. So for things like heat shields, that's something that could certainly show up in the next few years, carbon nanotube based or graphene based heat shields. There's another thing that I know there's some interest in is uh, nanoparticle enhanced propulsion. The advantage here is that because nanoparticles have a lot of surface area in comparison to their size, what that means for chemistry is that you have a lot more surface area in which to react. And so you can imagine that easily being used to create more efficient propellants. And so that's another thing that within the next 5 or 10 years, you can imagine those in rocket fuel, for example. Neither of those are anything quite as glamorous as a space elevator, but they are ways in which, again, these nanomaterials are very useful in a wide variety of fields. And I know another one that's being discussed is the use of, I mentioned earlier that there's like nanomaterial that can remove CO2 from the atmosphere. I know that's also being discussed in the context of life support systems on spacecraft.
Are we going to see any of this within 5 years, or what do you think a reasonable timeline is?
I think uh, I know there's definitely using nanomaterials in aerospace parts or coatings is something that's already happening and will continue to grow in the next 5 years. The other applications I mentioned are, I think, if I had to guess, just based on my perspective, is stuff we'll see in the 2030s or something.
Wow. So is the R&D related to how much money is being spent in the R&D, or is it related to the fact that it just takes a lot of time, a lot of iterations, a lot of research, and that takes years, no matter what the money is that's thrown at it?
I think there's a mix of both. I think it just takes the what we have now is we know these materials exist, but we just need there just needs to be these incremental improvements in how to actually make them, and that's something that just takes time and just continued effort. But I think even though it's been many years since carbon nanotubes and graphene were discovered, and there's this very real sense that they haven't delivered. Now what we are seeing is that there's increased private sector interest in manufacturing them and increased like startups that are trying to scale up their manufacturing of carbon nanotubes. So if there's any game changer, to use that word, I think just that increased interest will be what does it.
You mentioned propulsion. What about
Mhm.
showing up in our commercial automobile and transportation industries? So anything for my Toyota or looking at individual car, assuming we'll still be driving and everything won't be Waymo.
Right. Yeah, the big area for search and that in the automotive industry is that there's nanomaterials used in in certain types of batteries because as I mentioned earlier, one of the big advantages of creating nanoparticles is that you have more surface area for chemical reactions to happen. In ion-based batteries, what this means is that you have more surface area for ions to grab onto. And so while I don't believe any of these are quite in vehicles yet, within the next 10 years, perhaps, I think we'll see vehicle batteries that really take advantage of this, which isn't really fuel, but I hope that answers your question.
So I remember as a young kid when radial tires hit the market. I mean, maybe some of you that are younger probably think they've been with us forever, but their big advertising was steel cords. Remember, you had the Michelin steel guy that looked like the Marshmallow Man, but steel. Um, is it being used in tires and things like that, or the material's not prime time yet?
Not to my knowledge, though. Unfortunately, tires are a major source of environmental nanoparticles because of little tiny particles of rubber breaking off, but that wasn't really the question you asked.
So, back in 2013, somebody published that they'd made a half-meter long carbon nanotube. I don't know if that was ever reproduced by other researchers or if it was discredited, but I mean, it's a lot of time. That's like 13 years ago now, and I don't think anybody's beaten the record, even if it was a real record. What do you know about the progress in terms of making long carbon nanotubes? Has any product been made out of a carbon nanotube yet? That's like a tennis racket string or something?
No, yeah, that's what I was alluding to earlier. The research has really focused on trying to make less defect nanotubes with fewer defects over making longer nanotubes. So yeah, in that sense, the that to my knowledge, that actually is still the record for the longest nanotube. But I believe there are now carbon fiber products that do have nanotubes added to them that give them enhanced flexibility and enhanced strength. So again, not exactly glamorous, but it is something that's happening.
Is that just like marketing carbon nanotubes, like saying, we threw some carbon nanotubes in here to make it sound like this carbon fiber is better, but it doesn't actually add any value, or
I think I'm sure some of it is that, but one of the areas where this is getting a bit of attention is in things like aircraft parts, where they do actually have a meaningful impact on performance.
So in space, we talk about 2030, maybe human space flight, maybe a moon base, maybe the first mission to Mars around that time or 2040. Uh, is the development and the application of these nanotubes sort of on the same time scale, like 2030, we might see some practical use 2040, maybe more. It seems like what you're saying is it almost has a parallel track to our capability for large scale human spaceflight.
Yeah, I think it is a very real parallel. There's also I think a parallel in that there's an eternal sense that this is just X years away, but there's never been any movement. But I do think just as we're seeing slow progress towards that future of regular human presence in space, I think there's a similar slow progress towards widespread use of carbon nanotubes and also more so graphene, which has, I think, very much, we've been talking about carbon nanotubes, but more than that, graphene, which also could theoretically be used as a space elevator tether material, is really the one that has a lot more immediate potential. And I think within the 2030s, I think we'll really start to see it enter the a wider field.
What is the actual difference between a carbon nanotube and graphene?
Graphene is essentially if you take a carbon nanotube, cut it, and then roll it out into a flat sheet, what you get is graphene. They are both very strong, but because graphene is flat, it's possible to do more things that involve like flat sheets as an application.
I saw a discussion of multi-wall carbon nanotubes versus single-wall carbon nanotubes. So, what's the difference there, and how do they make them differently?
Yeah, there's multi-walled carbon nanotubes are essentially just uh, uh, you take one carbon nanotube and stuff it inside another, and you can create many layers like this. The sorry, the advantage of this is that these are actually in some ways easier to create, and in some applications can be sturdier. But one of the in doing so, you do sort of lose the like tensile strength that is one of carbon nanotubes' main advantages. So if you create too many walls, it actually can weaken the nanotube.
Are you excited about the potential going forward for carbon nanotubes? Are you a little bit disappointed and reserved given your book and your research and nightmares and fanciful predictions that never come true?
I think
What's your state of mind on this?
I think I'm cautiously optimistic, if I had to say. I think it's while again, I don't think it's realistic to expect like a carbon nanotube based or graphene based industrial revolution to happen overnight. I do think that many researchers and engineers in many fields recognize the potential of these materials, what they can do in everything from medicine to space exploration to environmental engineering. And I think so very slowly over the next over a time frame that might be too long for some people's interest, perhaps. I do think we will see them really start to make a difference. But I think it will be, I expect that it will be more of a quiet change than a sudden revolution, as I said earlier, as I think some people expect.
Do you, would these products have the same or better properties on Mars or the moon than they have on Earth? Would they be about the same or would they be worse?
I think they would be, really depends on the application. I think for most they would be about the same. But for things that really depend on gravity, for example, I think with even a defects filled carbon nanotube, if we could make it in the proper format, could, for example, function as a space elevator tether on the moon or Mars significantly more easily than it could on Earth with its stronger gravity. That's something I know is being discussed.
Marshall, did you want to say something? You're
There
muted.
we go. Yeah, I was remembering about a year ago, I read something about mixing graphene with concrete to upgrade the compressibility, make it a lot harder and quote unquote, making roads, streets, and other structures last twice as long uh, under, various strenuous loads. And it's kind of like, is that real?
I mean, it's definitely there's definitely marketing speak in there, but the underlying science is real. That is something that civil engineers have tried to do is mix concrete with graphene to do that. There's another example is there's concrete with, I believe, titanium oxide nanoparticles that react with
Hmm.
pollution. It's This is something that has been tested in some real buildings. Is it These nanoparticles will react with pollutants in the surrounding air, and sort of you have it cleaning buildings, so to speak. That's another example of this. Again, it's with concrete, it's hard to say how much concrete in the future will actually use things like this, but
Mhm.
the underlying technology is there. It's being tested.
Hmm. Well, my next, you kind of implied cleaning the air with nanoparticles, and since I have allergies, gee, the thought of a nanoparticle that could literally suck the pollen out of the air would be a wonderful concept.
I also have allergies, and that would be very useful. I don't, sadly, I don't know of any research that specifically does that, but it's definitely in the area of what nanotechnology can do in the environment is find individual particulates and remove them or
Mhm.
react with them.
Um, First of all, I apologize for my allergies and sneezing and everything, but um, I received an email before the program from Carl, who I do not personally know, who is in Los Angeles and saw the program being advertised. And he said, David, please ask my questions. So since we're near the end of the program, the hour that we agreed upon, here is Carl's question, because it's a little off topic for us. But Carl says, I'm in LA and I am in the self-defense industry, including weapons and ammunition, as well as physical self-defense. I can go to lots of different websites and buy very stylish, bulletproof or bullet resistant clothing. I can buy shirts, I can buy sport coats, I can buy pants, and they claim that they will protect you almost as well as Kevlar wearing a vest. I don't know anyone who has used one or had to find out if that's a true statement, but can you take carbon nanotube fibers and put it into clothing? And would it provide a self-defense type of clothing for military personnel, for police officers, for others, rather than big, huge, bulky Kevlar vest and armor?
Theory, I think so, but it's to be honest, it's hard for me to say because I have not seen this particular application in research. But I do think if it's something that Kevlar can do, I think it is also something that carbon nanotubes or graphene could theoretically do.
So you could wove it into a thread to make clothing?
Yeah, or you could, more realistically in the immediate future, you could enhance something like carbon fiber by adding graphene to it, to the composite, or adding carbon nanotubes to the composite, and something like that would be useful.
Um, Guys, we're coming up on the hour for our program today, so if you have any additional
Yeah,
comments
sure.
or anything, go for it.
Yeah, I just curious about some of your background. Did you like where did you go to school, and where did you get your all your knowledge from? And yeah.
Sure, yeah. So I have a bachelor's in specifically physics from Vanderbilt University. And then from there, I did a master's in science journalism from NYU, and that's where I got into this. Most of this of what I got from this book came from talking to scientists who work in this field in varied aspects of nanoscience, and from just read from what they told me and from the research and reviews they pointed me to. That's from assembling those is really how I got this book together.
Is this your
So
first book?
you're more of a science journalist, and you've been
Yeah,
interfacing with the people in the labs. Like
yeah,
what sort of
exactly.
labs have you talked to? Like there's one in the UK, right? There's a graphene
Yeah,
nanotube lab.
you're
Did you go
pro
there?
you're probably thinking of the one in Manchester, which is where graphene was actually first discovered. I didn't go there in person, but am Uh, I very much am aware of their research, but for example, I talked to one of a lab at Duke, which works with environmental nanopollutants. They do a lot of work of examining what nanoparticles do in the environment and how they can be removed. There's also another lab I spoke to at Northwestern, which does a lot of trying to integrate nanotechnology into electronics, creating very tiny circuitry. That's one lab out of many doing that. So,
Um,
yeah, those are a few examples.
um,
One thing I was wanting to ask about, you mentioned rocket fuels. Would these be solid or liquid or both? Do you think that they could put some nano technology in?
I believe both, but I think especially liquid, to my knowledge.
Mhm. Because
is your
there've been, historically, there's a lot of discussion of exotic chemicals, but they never really went anywhere. Hydrogen, oxygen was kind of the peak that's ever been done. There was other things they discussed back in the 50s and early 60s, but for a variety of reasons, they weren't practical. But this could maybe enhance the specific impulse beyond.
I think so.
Will your book be available in print on Amazon United States or only Kindle? Because it's been pointed out that it's in print in the United Kingdom.
Yeah, to my knowledge, I think it is on Amazon US. It's only available in electronic form, but you can definitely it's definitely available in print from Amazon.co.uk and from their other US from other non-US publishers. It's non-US booksellers, sorry, it's available in print.
Will it be in print in the US or this is the way it is?
I think this is the way it is, but if you do want it in print, there is a bookseller called Blackwell's, which does do free shipping to the US.
Blackwell's, WELLS.
Yes, yes.
What is this your first book and what's your next book?
This is my first book, yes. I do have a few ideas for my next book, but none of them are quite final yet.
Do you have any closing comments, anything you would like to leave with us on the topic or your book?
Nothing in particular. Thank you very much for having me on and allowing me to
Uh,
discuss in ways
Guys,
that hopefully make sense.
anyone with us that has a closing comment or question or anything they'd like to say? So we certainly thank you for sharing your knowledge on this subject with us. If you do put together another book down the road, let us know. And
Yes, thank you.
I'm assuming it would be science or space or both related, correct?
Most likely, yes.
So are you headquartered in New York or are you headquartered in Europe?
I'm currently visiting the US, but I am mostly based in Europe.
And is that the UK or somewhere else?
Yes, the UK.
Okay. All right. Until the next time, we thank you very much
Yeah,
for being with us. And
yeah,
listeners on Sunday the 12th, and for those of you in the room, it's open lines discussion, and look forward to having you all there. Once again, we thank you very much, Rahul. Everybody have a great weekend coming up, and keep looking up, and hopefully the heat shield holds. I see the media is really dramatizing, if I can dramatize the word dramatize, the heat shield problems and NASA having had to change the trajectory. Of course, these are things we've been talking about for a long, long time. And some of our guests, like Dr. Mike Griffin, said, it's unsafe. You can't do this. And there's probably been a few others that have said the same thing. So I'm watching the drama with the talking heads on the different cable stations. I guess maybe they want to get a good market rating, right? So everybody, uh, good landing for our mission. And once again, Rahul, thank you, and we look forward to another one. And I want to thank your representative for helping us put this program together, LJ, if I'm getting her name right. And
yes.
until the next time, once again,
Thank you very much.
great weekend, everybody. Goodbye from the space show.